Hello, my name is Kyle Sexton. I am an engineering manager at a company called New Context. And today I'm going to be speaking with you about Kubernetes. To understand the origin of Kubernetes, you have to look at Google. They have a system there that they run called Borg, and it runs hundreds of thousands of jobs every single day. Three people who helped work on Borg and create it decided they wanted to take their knowledge and learnings and create an open source product, and that's how we got Kubernetes. To understand Kubernetes, you have to understand it's a container orchestrator, and to understand that, you have to have an understanding of what containers gave us. Containers allowed us to package an application together with its dependencies. So a developer could compile and get everything in one package, and the same package would run because it's the same thing. You didn't have to worry about dependencies missing. And once you have that package, you can have that same single artifact go between all of your different environments. So the same package will go between dev, stage, and prod. It also gave us immutability. Instead of logging on to a server to upgrade, some package, you instead create a new container and just release a new version, which also allows you to easily roll back to a previous version. So container application dependencies, a single artifact promoting, and package immutability gives us this pattern for packaging our applications. So now that you have these nicely packaged applications, how do you get them to run across all of your nodes, all of your servers in your data center or in the cloud? Kubernetes takes those containers and puts them into something they call pods. You can think of pods as containers working nicely together. It's like containers that have common things, common features. And with pods, you get the advantage of things like health checks and resource constraints. So you can say, I need to know that this pod will run on this node in my cluster. And then Kubernetes takes that a step further with something called ReplicaSets. ReplicaSets allow you to take those pods and easily scale them from 1 to 100, or 10 or 15, or kind of however many you want, you can scale up and down. And then a step further, it takes those replica sets and manages them with deployments so that you can easily go from version 1.0 and roll out version 2.0 or roll back to version 1.0. And the architecture of this is all decoupled. So deployments manage your replica sets manage your pods, and your pods manage your containers. And so just like containers gave us a pattern for packaging our application, Kubernetes gives us a pattern for our application lifecycle. So one of the common complaints I hear about Kubernetes is that it's complex. Containers, pods, things I haven't even talked about, like daemon sets and stateful sets, all sorts of things. And it is complex. But I would argue that that's a necessary complexity. Homegrown solutions, in-house solutions, those become complex as well, especially as you start adding band-aids and features and things grow. The advantage of something like Kubernetes is that it's a hirable complexity. It's very easy to go find someone who knows Kubernetes or get people trained on Kubernetes. That's not necessarily the case for custom homegrown solutions. The Kubernetes project is managed by the Cloud Native Computing Foundation. And so these are the ones that are managing the forward-looking plans. They're managing certifications and training and things like that. So it's one governing body. That's my talk. Thank you all very much.